So we're going to make a proof, and we're going to have our statements on the left and our reasons on the right. What's our first statement going to be? The given. So we write AB is congruent to DE, and DB is congruent to AE. So here they have the tick marks for AB and DE, and then we need the tick marks for DB and AE. So I'll put 2 tick marks to show that AE is congruent to DB. And what's our reason for step 1? Given. So we need to prove that these 2 triangles are congruent. So we have 2 sides already. Do we have a third side or any angles we know that are congruent? DE and AB. We already said that one was congruent in the given. It's right here. So remember, we're looking at this triangle and this one. DA, and what's DA congruent to in both triangles? DA. So step 2 is DA is congruent to DA. And what's our reason there? Reflexive. So I'm going to put 3 tick marks there. So now we have that 3 pairs of sides are congruent. Alexis?
Are there going to be any proofs on tests?
No. No. Yes. Do we know that these 2 triangles are congruent now?
Yes.
Yes, so we can say triangle ABD, ADB is congruent to triangle DAE. And how do we know that these 2 triangles are congruent? What's our reason? SSS, because we have 3 pairs of congruent sides. So side, side, side. Okay, we're going to skip 7 and 8. The answers to 7 and 8 are on Canvas, so if you guys have any questions, I'll answer those later. But let's look at 9. So we're going to have our statements on the left and our reasons on the right. So what's our first statement going to be? The given. So PQ is congruent to RQ, and PS is congruent to RS. And what's our reason? Given. So here we need to prove that QS bisects angle PQR. Can we tell anything else from the picture that's given about the 2 triangles? That they're congruent? How do we know that they're congruent? Well, we have 2 pairs of sides that are congruent, so we need something else. We need either an angle. Peter? The reflexive. So we can say in step 2 that QS is congruent to QS. And our reason is because it's reflexive. So now I'll put 3 tick marks in the middle. So now can we prove that these two triangles are congruent? Yes. So we're going to say triangle PSQ is congruent to triangle RSQ. And what's our reason? Side, side, side. So now once that we prove that these two triangles are congruent, how can we tell that all of their parts are congruent? What? But like, how do we know that the angles are congruent too? CPCTC. So, yes. We're trying to prove that QS is bisecting this angle and this angle. So we need to prove that these two angles are congruent. So how do we know that these two angles are congruent, Sam? Because CPCTC. So we're going to say angle PQS is congruent to angle RQS. And because corresponding parts of congruent triangles are congruent. So now that we know that those two angles are congruent, do we know that QS is bisecting PQR? Yes. So step 5, we're going to write what we're trying to prove. So that QS bisects angle PQR. And how do we know that it's bisecting? What's our reason here? Definition of angle bisector. Remember, definitions are biconditional. So if we have that two angles are congruent, we know that the line is bisecting them. And the same thing works the other way. If a line's bisecting, then we have two pairs of congruent angles. So definitions work both ways. So the definition of angle bisector is what we're going to use in step 5. So we wrote what we're trying to prove is, are we done? Yes. So this is number 9. All right, let's take a look at number 10. Find each value. So we're trying to find x. We equal it to 60. How do we know that this angle is going to equal 60? Because it's equilateral, and because it's equilateral, we know it's equal angular too. So we set 45 minus 3x equal to 60. Then we solve for x. And what do we get for x? X is equal to negative 5. Okay, let's look at number 11. How can we find RS? What do we need to do?
Equal them to each other.
We equal them to each other. How do we know that these two are equal? What type of triangle is it? Isosceles. So because these angles are congruent, we know that their opposite sides are going to be congruent. So this side's congruent to this one, so we can just set them equal. So we have 2y minus 4.5 is equal to 1.5y. And now we solve for y. So we can add 4.5 to both sides and subtract 1.5y. So we get 0.5y is equal to 4.5. We divide by 0.5, and what do we get for y? 9. Is that our answer? No, what do we need to do? So we plug it into RS. So now we have 1.5 times 9, which is equal to 13.5. So that's our answer for RS. RS is equal to 13.5. Perfect. All right, chapter 5. Find each measure. So how do we find the measure of BD? 3.7 plus 3.7. And what do we get for BD? 7.4. How do we find the measure of YZ in number 2? Alexis.
What I did was that I put 3n plus 5 equal to 8n minus 9.
Perfect. 3n plus 5 is equal to 8n minus 9. And then we solve for n. What'd you get for n? So 14 over 5, or 2.8. Is that our answer? No, we need to plug it back in. So we plug it into YZ. And what did you guys get for YZ? 13.4. Okay, let's look at number 3. Find the measure of angle MNP. So we're looking for this whole angle here. How can we find this angle? We can set the two angles equal to each other. So we do 2z plus 10 is equal to 4z minus 6. So we subtract 2z from both sides, and we can add 6 to both sides. So we get 16 is equal to 2z. Divide both sides by 2, so we get 8 is equal to z. What do we need to do next? Plug it into where? Either one. So we can plug it into 4z minus 6. And what do we get for angle VNP when we plug it in? 26. But we need to find the two angles added together. So what do we need to do to 26? Multiply it by 2. So what do we get for the measure of angle MNP? 52. Perfect. Okay, let's look at number 4. How do we find the measure of BC? It's half of 70.2. So what's half of 70.2? 35.1. Number 5. How do we find XZ? 34.4 times 2. So what's 34.4 times 2? 64.8. 32.4 times 2. Oh, my bad. So 64.8. Number 6, how do we find the measure of BCZ? So this angle right here. 42, because we know that this line's parallel to this one. So we have a pair of alternate interior angles here and here. So BCZ is congruent to 42. So 42 degrees. How can we find the measure of BAX?
Oh, you said it'd be like they're same siding.
Yeah, so we have a parallel line here and here.
Yeah,
And this.
180.
So we do 180 minus 42. And what do we get for BAX?
Oh,
138. Okay, number 8. How do we find the measure of y, x, z?
Because like ABC and BCZ are alternate interior, and then BCZ and YXZ they're corresponding.
So, yes. So what would the measure of y, x, z be? 42. Right, there's multiple ways we can do this one. We know that these two lines are parallel, AB and XZ, and this is our transversal. So since BAX was 138, we know that YXZ is going to be supplementary to it. So we would do 180 minus 138, and we get 42. Number 9, write the sides of triangle ABC in order from shortest to longest. So what's our shortest side going to be? CB. What's our second shortest? AC. And what's our longest side? AB. Perfect. Remember, when naming the sides, you have to name it by 2 capital letters, okay? This side is side CB or BC. You can't just call it side B, okay? A lot of people made that mistake on the last test. Let's look at 10. Write the angles of triangle FGH in order from smallest to largest. So what's our smallest angle we have here? Angle F. What's our second smallest? Angle H. And what's our largest angle? Angle G. Remember, the smallest angle is going to be opposite of the smallest side. (11) says the lengths of 2 sides of a triangle are 13.5 centimeters and 4.5 centimeters. Find the length of the possible lengths for the third side. So we're going to have is greater than some number and x is less than some number. How do we find this number on the left? We subtract. So we do 13.5 minus 4.5. What do we get? 9. How do we find the number on the right? We add the 2. So 13.5 plus 4.5. What do we get? 18. So the range of possible lengths for the third side is going to be greater than 9 and less than 18. (12) Tell whether the triangle can have sides with the given lengths. What do we need to do here? 6.2 plus 8.1. And what do we get? 14.3. Are these 2 sides greater than the third side? Yes. So can this be a triangle? Yes. Okay, 13. We have sides Z, Z, and 3Z when Z is equal to 5. So what do we need to do first? So plug in. So we have a triangle with sides of 5, 5, and 15. So which 2 can we start to add? 5 plus 5. We get 10. Is 10 greater than 15? No. So can this be a triangle? No.